Good day, everyone. So, the topic that was given to me is about National Electrical Code from chapters 4 to 6. So, first is Article 430.36, Fuses in which conductor. Where fuses are used for motor overload protection, a fuse shall be inserted in each underground conductor and also in the grounded conductor if the supply system is 3-wire 3-phase AC with one conductor grounded. So here's how fuses works. When the current flows through the circuit, it heats up the fuse wire. And when there's a heavy current in the circuit, the wire simply melts, resulting in the broken circuit. Yes, the circuit breaks and the current does not reach the appliance. When the fuse breaks, you need to change it manually. But some automatic fuses are used nowadays. It is called MCB or miniature circuit breaker. When it detects a heavy current, it will automatically switch off. And if the current goes back to normal, it will automatically switch on. That's why we need fuse in our circuit breaker. Next is Article 402.5, Allowable Opacities for Fixture Wires. The allowable opacity of fixture wire shall be as specified in Table 402.5. No conductor shall be used under such condition that its operating temperature exceeds the temperature specified in Table 402.3 for the type of insulation involved. So here is the table of allowable opacity for fixture wires. There are sizes 18, 16, 14, 12, and 10. And its allowable opacity 6, 8, 17, 23, and 28. So next is Article 500.7, Protection Techniques. Section 500.7 A through L shall be acceptable protection techniques for electrical and electronic equipment in hazardous classified locations. Letter A. Explosion-proof equipment. This protection technique shall be permitted for equipment in Class 1, Division 1 or 2 location. So in this equipment, explosion-proof enclosure are designed so that escaping gases will be sufficiently cooled as they exit through openings that are long in proportion to their width. Letter B. Dust ignition proof. This protection technique shall be permitted for equipment in Class 2, Division 1 or 2 locations. This equipment enclosed in a manner that excludes dust and does not permit arcs, sparks, or heat otherwise generated or liberated inside of the enclosure to cause ignition of exterior accumulation or atmospheric suspension of a specified dust on or in the vicinity of the enclosure. Letter C. Dust tight. This protection technique shall be permitted for equipment in Class 2, Division 2 or Class 3, Division 1 or 2 locations. In this, sealed switch will withstand sand and dust contamination, constructed so that dust will not enter the enclosing case under specified test conditions. Letter D. Purged and pressurized. This protection technique shall be permitted for equipment in any hazardous classified location for which it is identified. Purging is defined as the process of supplying an enclosure with a protective gas at a sufficient flow and positive pressure to reduce the concentration of any flammable gas or vapor initially present to an acceptable level. To put it simply, before an area can be pressurized, it must be purged of the current air. Pressure must be maintained at a level of at least 25 Pascal or 0.1 inches of water, with all openings closed, and must provide a minimum of 0.305 millisecond or 60 feet per minute through all openings capable of being opened. Letter E. Intrinsic safety. This protection technique shall be permitted for equipment in Class 1, Division 1 or 2, Class 2, Division 1 or 2, or Class 3, Division 1 or 2 locations. The provisions of Articles 501 through 503 and Articles 510 through 516 shall not be considered applicable to such installations, except as required by Article 504, and installation of intrinsically safe apparatus and wiring shall be in accordance with the requirements of Article 504. So, intrinsically safe equipment is defined as equipment and wiring which is incapable of releasing sufficient electrical or thermal energy under normal or abnormal conditions to cause ignition of a specific hazardous atmospheric mixture in its most easily ignited concentration. This is achieved by limiting the amount of power available to the electrical equipment in the hazardous area to a level below that which will ignite the gases. Letter F. Non-Indisensive Circuit. This protection technique shall be permitted for equipment Class 1, Division 2, Class 2, Division 2, or Class 3, Division 1 or 2 locations. It is a protection technique that prevents electrical circuits from causing a fire or explosion in a hazardous location under normal conditions. Letter G. Non-indisensive equipment. This protection technique shall be permitted for equipment in Class 1, Division 2, Class 2, Division 2, or Class 3, Division 1 or 2 locations. Equipment having a electrical or electronic circuitry that is incapable, under normal operating conditions, of causing ignition of a specified flammable gas air, vapor air, or dust air mixture due to arcing or thermal means. Letter H. Non-indisensive component. This protection technique shall be permitted for equipment in Class 1, Division 2, Class 2, Division 2, or Class 3, Division 1 or 2 locations. It is a component having contacts for making or breaking an incendive circuit, and the contacting mechanism is constructed so that the component is incapable of igniting the specified flammable gas or vapor air mixture. Letter I. Oil immersion. This protection technique shall be permitted for current interrupting contacts in Class 1 Division 2 locations as described in 501.115B12. Oil immersion is a technique used to increase the resolving power of a microscope. This is achieved by immersing both the objective lens and the specimen in a transparent oil of high refractive index, thereby increasing the numerical aperture of the objective lens. Letter J. Hermetically sealed. This protection technique shall be permitted for equipment in Class 1 Division 2, Class 2 Division 2, or Class 3 Division 1 or 2 locations. A hermetically sealed container or space is so tightly closed that no air can leave or enter it, separated and protected from very different conditions outside in a natural way. Letter K. Combustible Gas Detection System. A combustible gas detection system shall be permitted as a means of protection in industrial establishments with restricted public access and where the conditions of maintenance and supervision ensure that only qualified persons service the installation. Where such a system is installed, equipment specified in 500.7 K1, K2, or K3 shall be permitted. A combustible gas detector is a device used to detect the presence of combustible, flammable, toxic, and oxygen-depleting gases in an area. They are commonly used in an industrial plants to detect gas leakage or build-up before it can reach an explosive level. Number 1. Inadequate ventilation. In a Class 1, Division 1 location that is so classified due to inadequate ventilation, electrical equipment suitable for Class 1 Division 2 location shall be permitted. Combustible gas detection equipment shall be listed for Class 1 Division 1 for the appropriate material group and for the detection of the specific gas or vapor to be encountered. Inadequate ventilation can lead to the buildup of small amounts of contaminants which are difficult to identify and test. So carbon dioxide levels are used as an indicator of adequate ventilation in a room. Carbon dioxide is released by combustion of fuels and every time we breathe. It is normally measured at 300 to 350 parts per million in the atmosphere. Number 2. Interior of a building. In a building located in or with opening into a Class 1 Division 2 location where the interior does not contain a source of flammable gas or vapor, electrical equipment for Unclassified locations shall be permitted. Combustible gas detection equipment shall be listed for Class 1 Division 1 or Class 1 Division 2 for the appropriate material group, and for the detection of the specific gas or vapor to be encountered. Interior of a building is design of a building or shelter from inside out, or the design of a new interior for a type of home that can be fixed. It can refer to the initial design and plan used for a building's interior to that interior's later redesign made to accommodate a changed purpose, or to the significant revision of an original design for the adaptive reuse of the shell of the building concerned. Number 3. Interior of a control panel. In the interior of control panel containing instrumentation utilizing or measuring flammable liquid gases or vapors, electrical equipment suitable for Class 1 Division 2 location shall be permitted. Combustible gas detection equipment shall be listed for Class 1 Division 1 for the appropriate material group and detection of the specific gas or vapor to be encountered. Number 3. Interior of a control panel. An electrical control panel is a combination of electrical devices which use electrical power to control the various mechanical functions of industrial equipment or machinery. An electrical control panel includes two main categories: panel structure and electrical components. Letter L. Other protection techniques. Other protection techniques used in equipment identified for use in hazardous classified locations. Lastly, Article 680. Swimming pools, fountains, and similar installations. 680.10. Electric pool water heaters. All electric pool water heaters shall have the heating elements subdivided into loads not exceeding 48 amperes and protected at not over 60 amperes. The ampacity of the branch circuit conductors and the rating or setting of overcurrent productive devices shall not be less than 125% of the total nameplate rated load. That's all. Thank you.